Okay, so now we're going to prove part 2, but I just want to reference back to part 1. Okay, so what does this mean? So g prime of x is f of x. So what that means is that g is an antiderivative of f. So let me just put it down into real terms. So if I know that g of x is x cubed, and I know that f of x is 3x squared, g is an antiderivative of f because when I take the derivative of g, I get f, right? That's what an antiderivative is. If I take the derivative of this, I get this, right? Okay. So what if I said I know another antiderivative of f? So I'll call it capital G. Isn't capital G equaling this another antiderivative of this? It is, because if I take the derivative of capital G, I get little f, right? Okay, so that's how I'm going to move forward on the proof. So here I have this integral, and I've got this capital F going on. Okay, so let's see what I can do. So I'm going to say, all right, if I know capital F is an antiderivative of f, I already know g is an antiderivative, right? So I have g and capital F are both antiderivatives of little f. So the difference between, like this one and this one, the only difference between the two of them is that there's a constant difference, right? So I'm going to say that this capital F is different from g by just a constant, right? So just different by a constant. Okay. So now I'm going to play with these a's and b's. So what will g of a, or f of a be? So that means I'm going to put a in here, right? Now I'm still using that definition of g from the beginning. So now think about it. What's g of a going to be? G of a means putting in x equal a, right? So what happens when I get x equal a? I get integral from a to a of f of t dt. And what do you know that this integral is? That's 0, right? So f of a equals just c. All right, so what about f of b? So f of b will be the same thing as saying g of b plus c. So that's going to be the integral from a to b of f of t dt plus c. Okay, so let's put this together. So what they're saying is this integral from a to b of f of x dx is equal to f of b minus f of a. So what's f of b equal to? F of b is a to b f of t dt plus c, subtract, and what's f of a equaling? C. Oh, so so the c's cancel, so what I'm left with is the integral of f of t dt. Okay, so what that's giving me is that this integral from a to b of f of t dt is equal to the antiderivative, right, with b plugged in and with a plugged in. So I take what the antiderivative is. So this is the new notation I want you to get used to. You take the antiderivative, and then you say, okay, then I'm going to plug in a and b. You plug in the top number first, and then you subtract off plugging in the bottom number. So the area under the curve is connected to the derivative because it's the antiderivative. So the integral and the derivative are connected through the fundamental theorem of calculus.